Hi there. In this video, I'm going to be focusing on a specific condition which is embryological called Smith-Lemli-Opitz. I'm going to be explaining how in this condition there is a biochemical abnormality which leads to defective embryogenesis and can with specific patterns. First of all, what is Smith-Lemli-Opitz? It is a syndrome that's due to a deficiency in a specific enzyme called 7-dehydrocholesterol reductase. Cholesterol synthesis is a very large multi-step process, and the step just before producing cholesterol is the reduction of dehydrocholesterol to cholesterol. In Smith-Lemli-Opitz syndrome, this particular enzyme is deficient. It's autosomal recessive, as with most enzyme deficiency, inherited enzyme deficiency syndromes. What is the biochemical and embryological significance of all this? Well, firstly, cholesterol is needed for two very important aspects of embryogenesis. On the one hand, it's very important for the development of midline structures, particularly in the head and face, anteriorly, or we call ventrally, and also it's very important for sexual differentiation. So let me first of all explain about the midline defects. There is a gene called sonic hedgehog. Now it's not this. It's found in your genes. It's found in your genome, and it's called sonic hedgehog, and it plays a very important role in the signaling the development of your anterior midline structures in utero. Cholesterol essentially acts as the conduit molecule for the epitopes of sonic hedgehog. So you have your sonic hedgehog gene, which makes the protein signals, and these basically associate themselves with cholesterol. And as cholesterol is distributed around the embryo, the signal of sonic hedgehog is distributed, resulting in the proper formation of midline anterior structures. So, what problems can happen if you have Smith-Lemli-Opitz? Well, firstly, you can have a condition called holoprosencephalopathy. No, holoprosencephaly. Let me break this down in terms of nomenclature. Holo means one, as in whole. Prosencephaly. So we talked in a previous video about how in brain development you have primary and secondary brain vesicles. So one of the primary brain vesicles is called the prosencephalon, which is towards the head, which develops into the two telencephalons and also the one diencephalon. Two diencephalons, which fuse obviously to form one thalamus, one hypothalamus, but so what happens then? Why do you get holoprosencephaly in Smith-Lemli-Opitz syndrome? The reason for this is that due to a deficiency in 7-dehydrocholesterol reductase, you don't form cholesterol in utero. This results in the inability of sonic hedgehog gene to distribute its gene products, its signaling products around the ventral and into the ventral structures to properly form the midline structures. This can lead to craniofacial defects such as cleft lip and cleft palate. It can lead to basically union of the lateral ventricles, where you normally have two, you have one, and also union of the orbits, leading to cycloplia, or one eye, although this is a particularly rare and severe form. So I've explained about the anterior defects in Smith-Lemli-Opitz. I'm now going to talk about the disorder of sexual differentiation that you may see in Smith-Lemli-Opitz. The reason for this disorder is because of the deficiency of cholesterol. Now, the downstream products of the cholesterol pathway are, of course, your sex hormones, which are testosterone and estradiol. So, if you are karyotypically male and you have this genetic syndrome, you can have you will still have your anti-Müllerian hormone, which disintegrates the paramesonephric ducts and produces the testis, contributes to the testis production and the formation of the I can't even say that, the vas deferens and the spermiferous tubules, seminiferous, there you go, seminiferous tubules. However, you lack the potent dihydrotestosterone to differentiate the external genitalia. This can result in ambiguous genitalia in a karyotypically 46XY boy. In females, similarly, they lack the anti-Müllerian hormone, and so they form the paramesonephric ducts. However, they lack the cholesterol signals to form the secondary sexual characteristic, to form the external genitalia. And so the children may be born with ambiguous genitalia, may be born with a midline defect or a holoprosencephaly, specifically also a cleft lip or a cleft palate. So if I can summarize, in this video, I have focused on a condition called Smith-Lemli-Opitz. I have explained the biochemical problem and the genetics of this condition, and also the biochemical consequences of this. On the one hand, in disrupting sonic hedgehog signaling, which leads to potentially midline defects, and also a disorder of sexual differentiation, which is a consequence of low levels of testosterone or estrogen. Nevertheless, you still have you can still have anti-Müllerian hormone if you're a boy with this syndrome. So I hope you have gotten a bit of an insight into cholesterol biosynthesis and its crucial role in embryogenesis. Thank you very much.